Hello again, fun with math stuff, geometry, symmetries. So we're looking at symmetry of two-dimensional figures and a little bit with three-dimensional figures. The 3D one's harder because you gotta have a good picture of it or the object to play with. 2 dimensions a little easier to look at. So the first stage of the project is to identify the symmetries of each of these blocks. And so I think I will take the last one to play with here. And which one do I want to use? I think I'm going to use the toy theater today. And that's probably fine. And so I'm going to play with this one here. It looks relatively horizontal. Screenshot it so I can draw on it. And current page. Let's make that sucker a little bigger. And magic pen. Cool, works today. All right, so we've got two-dimensional symmetry. And first I'm going to start off with the reflectional symmetry of this object. And with the reflectional symmetry, we're looking for a line of symmetry. That we can draw that one side matches the other. So I believe if I come down through the middle here, about there, there's a line such that the left side is a mirror image of the right side of this figure. And to double check that symmetry, I'm going to pick a point. Let's say that one's a nice one to pick right there. And it should have a partner point on the other side over there, such that when I connect those 2 points, 2 things happen. One, the line connecting the points meets the line of symmetry at a right angle. And 2, the distance from the point to the line of symmetry is the same as the distance to its reflectional point and the line of symmetry. So these distances are the same on each side. So that means this is a line of symmetry if that's true for any point you pick. Okay, not just for one point, but for every single point, that's got to be true. So if we were to pick a different point, let's erase the stuff. And try to find its symmetrical partner, like let's suppose we picked this point right here on the figure. And then again, we believe that this is the line of symmetry right there. And that's a tad bit off, but let's go with it anyway. I want to find its partner point. So let's go oops, wrong color, but that's okay. Perpendicular through there. It should have a matching point on the other side here, such that there's a right angle there and this distance matches that distance right there, okay, for every single point you can pick. All right, so for sure we have that one line of symmetry there. Label that one and get rid of this extra stuff. Oop, no, you stay. I want to get rid of the point. There we go. Point. Oh, fine, we'll just start over. Is that my eraser? Yep. All right, so then identifying any others, it looks like there's another line this way through the figure, and looks like I'm a little off again. And maybe it's gonna be easier to move the figure. All right, so it looks like when I brought my figure in here, it wasn't quite horizontal, but I'm pretty close there. And so again, I believe that's a line of symmetry also, because I could pick 2 points and the reflection will be perpendicular through the line of symmetry. So my 2 lines of symmetry are these 2. And my accuracy isn't great today. All right, so those are my lines of symmetry for reflective symmetry. So it says 2 lines of symmetry And what I'm hoping for is a sketch from you and a brief explanation. And I could say they are through opposite, let's see, yeah, opposite vertices. Some figures have lines of symmetry that go through the midpoints of sides, but if we tried to do that here, like we pick the midpoint of this side, which is about here, and go to the midpoint of that side there. Oops, I meant that to be the line tool. Midpoint to midpoint. That does not look like a line of symmetry right there, that green line. And to double check, that's not a line of symmetry. I can pull out these other ones for a minute. And sometimes you do have to explore to see if there are any others. So that was about there. So I have cut the figure in half with that line by going, oops, close enough, from midpoint here to midpoint there. So again, I was trying to pick midpoints. There and there. And to test if that is a line of symmetry, then what I do is I pick a point on one side, like choose blue, this point right here, and I draw a perpendicular line from that through, let's see, where's perpendicular, 90-degree angle, about right there, you think? Why am I having a hard time seeing perpendicular? I'm gonna hold up a piece of paper to that. Oh no, that's not perpendicular. It would be way down there. Okay, let's try that again. Trying to get a right angle here. There maybe? Let's try that. Not quite. Third try is the charm. Let's see, I don't think that's a right angle. Definitely not a right angle. All right, you get what I'm saying? I'm having a hard time drawing right angles here. I don't know why. Okay, I'm gonna say that's a right angle right there. So then this point right here should have a symmetric partner on the other side that's equidistant. And every single point should have a partner equidistant anywhere I pick a point. And so I think their equidistant points would be around here. Oops, that's not a pen. Here, and so that's almost in the right spot, but not quite. This one would probably be about right there. That one would be over here, maybe. So that's not a line of symmetry, that green one. Sometimes it's pretty obvious, and sometimes it's not. But this one had two lines of symmetry. All right, eraser, clean up. And look for rotational symmetry. And there is a connection, come here, if I can catch that, there we go, between lines of symmetry and rotational symmetry. And one goal of this project is for you to try and find that. Come on. Relationship. So does this have rotational symmetry? So to test that out, I'm going to rotate this thing, and I keep moving it till it gets back to its original orientation. So hasn't happened yet, hasn't happened yet, hasn't happened yet. And it looks like finally when I get to 180 degrees, I'm back to where I started with the same shape as before. And one thing to note is my orientation of this wasn't quite right, or the way I grabbed it in the screen, my point of rotation there didn't match the lines of symmetry. So pen, this has 180-degree rotational symmetry. And what you should find is as you catalog the lines of symmetry and rotational symmetry for each of these figures back here, you should see that there's a connection between so having a certain number of lines of symmetry and a certain first rotational symmetry. So if you're not sure about that, be sure to write to the group and ask about that. So the next thing I'm going to do is, hopefully you've cataloged these, is let's make some shapes that have some symmetry to them. And we want to have some diverse figures there. So let's see, can I find my pre-made ones? Let's give it a shot. Hopefully they're on this computer. Unfortunately, I've got like 3 different computers I've been working on lately. So let me see, am I in documents? What? Oh, OneDrive, I don't use OneDrive. All right, work. And mth213. Okay, so here's some figures I was playing with. Let's check out this one right here. This was when I was playing around with tessellations. Come on, figure. There you go. So one question I had before is will this figure, can I continue this pattern and tessellate the plane? So that was one question. 2, if I can, is it a regular tessellation? Is it a semi-regular tessellation, or is it just some other weird tessellation? Because there's tons of different classifications of tessellations. And I will post this to the group chat soon, asking those questions and hoping you guys respond. But I can also use it to talk about symmetry. So I think this thing has some lines of symmetry, so I want to play around with that. So let's grab it into my screen to draw on. New page. Okay, so looking at that figure right there, I would like you to make an estimate of how many lines of symmetry you think this has. And on the outside, this is a convex polygon, and it has a lot of sides. How many sides does it have? I'll count those later. But for now, I'd like you to make an estimate of how many lines of symmetry it has, and please post that to the chat. And we'll test out your theories. So a lot of times what I do is I take a piece of paper and I hold the piece of paper up to it. Okay, I have a guess on how many I think it has. Please help me out here. Okay, we got one guess so far. I'm hoping for others. Okay, another guess. Excellent. Hoping for at least 2 more guesses. And one more, please. Okay, so we have 4, 12, 4, and 2. All right, let's take a peek. Line tool. Oops, wrong. There's my magic board. All right, and we'll do red lines of symmetry. So usually I'm drawn to like vertical and horizontal ones if they exist. And so I think there's a line of symmetry vertically there, but I missed. And it's bugging me if I don't move it. I can grab it, so come on, there you go. All right, so there's one line of symmetry for sure. And so let's label as we go. That's line number 1. Now, I think there's a similar one horizontally. So right about here-ish. Ooh, I did better that time. So there's another one there. So I'll label that one as line number 2. And these pointy things look like they may have something to do with the symmetry. So I'm going to draw one through those and hope. So if I start here-ish and go through there, that looks like a line of symmetry, right? So if I pick like this point here, so let's pick a different color, yellow maybe, I don't know if that'll stand out. So from this point here, if I go perpendicular through that line, I should end up over there. And then this point here and that point there. Let's get the, so that point and that point are the symmetric points. Their connection meets at a right angle here with the line of symmetry, and the distance from the line of symmetry to the symmetric point, the line of symmetry to the original point, are the same. Yeah, I think that looks good. So then it's got a matching one through the other pointy parts of this thing. So I forgot to label that. So this would be number 3 and pointy one. So you gotta grab these things and play with them, figure it out. Okay, so that one right there seems to be number 4. The question is, okay, so for sure we have 4 different lines of symmetry. Are there others? Okay, so if there's another line of symmetry, like maybe somehow through one of these orange squares, this is getting a little messy. Let's bring this to a new screen. New page, and test to see if there's any other lines of symmetry. So 4 seems to be the answer so far. So what if I went from here to there? Is that a line of symmetry? Okay, it looks like I'm heading through the center, right? So that would be important. And if so, then this point up here would connect perpendicular. So there's perpendicular and have a matching point on the other side equidistant, and there ain't no point over there. Okay, so I should have drawn that a different color. But so that isn't a line of symmetry here. So let's make a no. And I'm kind of running out of options on ways to draw those. So I guess I can erase and try one more time. Let's see, what else might be a line of symmetry? So a line of symmetry has to pass through a center because you're cutting the thing in half with a line of symmetry. Kind of, I don't know, anybody else? I don't see any others. I don't see a clever way to draw one from the middle of any of these sides. I guess I could go from like a vertex here to that matching vertex down there. Is that a line of symmetry? What's on one side is a mirror image of what's on the other. To test that out again, we pick a point and make a perpendicular line. I don't know if I can do that today, but I'll try. I failed earlier. So from this point, if I go perpendicular, and that's about perpendicular, I'm hoping for a point just like that over here, equidistant from there, and there's nothing out there, so nope. All right, so I don't think there's any others. I think we have, go back, looks like we have 4 lines of symmetry on this thing. So for this second part, I'm hoping you'll have some fun, make some interesting shapes. So let's see, 4 lines of symmetry. Okay, so then we look at rotational symmetry on this thing, and for that, I just kind of want to turn it till I see it's going to get back to where it started. Well, I could use these pointy things to do that. It's if I rotate around the center here, this isn't going to be in the same orientation till it gets over to there. So I could do that 1, 2, 3, and then 4 back where I started. So as far as rotational goes, based on those 4 lines of symmetry, if I take, oops, that was supposed to be a 6, 360 and divide by 4, I get what, 90 degrees to get this point over to there. So this has 90-degree rotational symmetry. All right, has anyone drawn an interesting shape that they want to try and share for this part? I'm really hoping somebody has something to share. Is that a no? So if you don't have a figure to share, could you confirm with a no? If you do have a figure to share, then please supply one. We got a no, and a no, and a no, and a not yet. Okay. So let's play. Let's make you go away. Let's see, did I make another one here? This was another one I was playing with. Will that tessellate? And I believe the other one would not. I think this one would tessellate, radiating out from the center. It's not regular because I don't use the same shape over and over again. Is it, what did the book call it? Semiregular was one of the ones the book went over. And so I'm going to post this to a group discussion soon, asking if this is, one, will it tessellate? Two, is it regular? Three, is it semi-regular? And you can see some symmetries here. So I think this, like the other figure I made, has 4 lines of symmetry. If it has 4 lines of symmetry, it should have 90-degree rotational symmetry. I'm going to make a new one. All right, so playground here. Well, I have that on the screen. I guess I could start with this sucker here and play. So what if I put this down? Ooh, they move each other. I can remember that happening before. Maybe I put that there. And then, well, let's throw you in there too. Come here. And let's throw you up here. Oh. Come on, move. There-ish. And then we'll throw you over here-ish. All right, tweak those a little bit. That one's out of place. Okay. Oh, stop. Okay, so there's my figure right there. Does this have any symmetry? Let's bring it to my notebook to play with it. What do you think? Does anybody see symmetry in there? New page. And let's blow it up a bit. Okay, so what do you think? Symmetry? Any? Question mark. So I'm being creative. I made a shape. I'm wondering about its symmetries. And if I go for my usual, let's draw a vertical line, maybe one. So like if I go through those 2 points there, so I'm going through this point and that point, perpendicular across, there should be a matching point. Now color is not that significant, but shape is. So this is not the same shape. The orange is not the same shape as the blue one. So it looks like this red line is not a line of symmetry. All right, so let's undo that. Maybe this way through there. And again, perpendicular from this point through, there's not a matching point on the other side. So that's not a line of symmetry. And I'm kind of running out of ideas for lines of symmetry. Let's play a little more, maybe from this point to that one. Is that a line of symmetry? If I then say, let's pick on, let's use green, this point right here, and I go to connect it to that point right there, notice they don't meet at a right angle. Okay, so that's not its symmetric point. That's the one I would like it to be symmetric to, but it ain't. Okay, so I don't see any lines of symmetry unless I'm mistaken, and I'm often mistaken. Okay, so I'm just going to make a note. I don't see any lines of symmetry. Does anybody see rotational symmetry? could I spin it around its center? So I would say its center is right in the middle of this pale block. Could I rotate it less than 360 degrees and get the same figure? So I'm gonna make a copy of itself and give that a try. Anyone want to chime in with a thought on that? Okay, Summer thinks it does have rotational symmetry. What angle do you think that symmetry would give me? First time I get a match. So it's not 90-degree rotational symmetry, 180, yeah, that's what I was thinking too. I was trying to do that when I made it. Oops, I lost it somehow. I messed that up somehow. Let's undo and try again. Hopefully I won't let go of it this time. To 180. Yeah, if I rotate it 180 degrees, I get a match to what I started with. Okay, so it doesn't have any lines of symmetry, but it does have 180-degree rotational symmetry. So 180-degree rotational symmetry. Rotational. Now, if I had made some different choices in the construction, like I put another orange block in place of the blue one and another orange block in place of the blue one, then I would have had two lines of symmetry to go with the 180-degree rotation. So just for fun, let's do that one. Slightly less exciting version. So if we say pull out that and pull out that and throw these there. As much fun as this one is to play with, sometimes it's slightly annoying. Okay, so there's my figure there. So let's copy you. Into a new page, please, and blow it up. So this one right here, I'm pretty sure is going to have 4 lines of symmetry. Or no, I lied, 2 lines of symmetry and 180-degree rotational symmetry. So there should be a line right, whoa, try that again. Line, there we go, line tool, and come down through the middle there. So that should be a line of symmetry. There should be another one roughly there-ish, pretty close. So those should be my 2 lines of symmetry. If I tried to draw another one, I don't think that's gonna work here. And we played around with that idea before. So I believe this thing right here has 2 lines of symmetry. And if I check the rotation, make a copy, and then rotate it, at 90 degrees right there, it's definitely not the same orientation. But then again, at 180, it is the same orientation. So this has 180-degree rotational symmetry. So one thing that seems to be true, if we have a figure that has 2 lines of symmetry, it should have 180-degree rotational symmetry. But a figure can have 180-degree rotational symmetry without having 2 lines of symmetry, but it's got some kind of reflection, some kind of skewness going on, but it still rotates, but it doesn't have that mirror image type symmetry. So there's a lot of different ways the symmetries fit together. But there are definitely some patterns that hold true all the time, like lines of symmetry versus rotation, but not the other way around. Okay, so your goal, if you haven't finished it, is to complete this chart up here where you tell me about the lines of symmetry of each of these figures. And you may have drawings and words is what I recommend, kind of like I was doing. Rotational symmetry, tell me about the rotational symmetry. And some figures have multiple rotational symmetries. So like, if we go back to that crazy thing, I wondered if it tessellated. Oh, there you are, right there. This thing right here, let's rotate it. So I can rotate it 90 degrees, stay still, it's the same shape I had before. I can rotate it 180 degrees, right there, it's the same shape I had before. And I can rotate it 270 degrees, it's the same shape I had before. So this one has multiple rotational symmetries. And when we describe a figure's rotational symmetry, we usually state it's the earliest one. So the smallest angle through which we get that rotational symmetry. So that's why I'm classifying this as 90-degree rotational symmetry. All right, back here. So once you get each of those classified in terms of their lines of symmetry and their rotational symmetry, and again, the main thing is here, how many lines of symmetry, what's the earliest rotational symmetry, and then why, right? So give me a sketch, tell me a little bit about it. Then you're gonna create 3 figures. So I have one here, I created a couple of others. Have fun with it, make some pretty pictures, and then get that to me. And so you can have, tell me how many lines there are and a brief explanation of them. Tell me its earliest rotational symmetry, and then a comment about that. And this should, let's double check, be set up for you to upload stuff. So you can take you can draw stuff on paper and take pictures of it, or you can do screenshots from those tools there. Yeah, so so you can file upload, stop it, many files, one at a time. So if I wanted to put that in there, I just grab it, drop it in there, and then I just pick another one, and I choose that one and drop it in there. If you want to do text entry, then you can put your pictures inside this box here. So you can, you could make that table we had if you really wanted to get creative. So what did that have? 3 columns and, oops, some rows. Let's put that many in for fun. And you could actually stick images in these boxes here. So I could grab an image, you would go to Canvas, and then My Files, and then find the file you want to upload. And you can stick them right in there. And if you did a screenshot, it's normally going to be pretty big because your screen is probably a high resolution. So then you want to adjust the size of it. So maybe I'll try what's 300 pixels, see what that looks like. It'll automatically calculate the other number for you, and it'll drop that image in there, and then you can tell me about its symmetries. So here's my thing, and then lines of symmetry. So if you want, you could type it up in here, or you could do it in a Google Doc, send me the Google Doc, do it in a Word doc, send the Word doc, however you want to do it. But have fun with it. This would be rotational. So you have a few options on how to get your work to me. I'm looking forward to seeing it. And then once you're done, submit. If you submit and you realize you're not done or you made a mistake, then you can always resubmit, and I'll see every time you resubmitted. Okay, so let us look at the next thing. Any questions on this, by the way? I think it's relatively straightforward. If you get stuck on it, again, let's see, do we have a discussion forum? I don't think I forgot to put one in this week. I did not. I can add a questions forum or just message me. So I'm going to leave the student view for now. Okay, so the next assignment, this one should be a discussion. Yeah, so other people are going to see your replies. So I'm going to post one right now. And I should take a photograph of it later, but I'm just going to show you something I threw in my notes here. mth213 notes, geometry. Okay, so these are some figures I was playing around with last class. I've got kind of an old-fashioned couch at home. It's not quite as ornate as this one right here, but a couch is a 3-dimensional object. And this couch, I could slice right down through the middle of this couch with a big chainsaw. And what I would have is the left side of the couch would be a mirror image of the right side of the couch. So 3D objects can have symmetry, and they don't have lines of symmetry, they have planes of symmetry. So a plane slices through the object, and that plane is a big old mirror. What happens on one side is a mirror image on the other side. So my couch at home has a single plane of symmetry. As for rotational symmetry with three-dimensional objects, I have a fan like this one at home. And let's open this up, a new tab, maybe it's bigger there, a little bit. So aside from the frame that's holding it, the fan itself, the blades, they have rotational symmetry. And so this one right here, since it has 3 blades, would be 360 divided by 3, which would be 120-degree rotational symmetry. So my couch doesn't have rotational symmetry. Instead, it has reflective symmetry. This fan right here is a three-dimensional object, and it has rotational symmetry with these blades here. I don't believe this fan, though, has any lines of symmetry or planar symmetry. Like if we were to slice through right here on this, we do not have a mirror image. Yeah, so this has rotational symmetry only, but it does not have planar symmetry, reflective symmetry. So in 2 dimensions, we slice with a line. In 3 dimensions, we slice with a plane. And a knife blade is kind of like a plane, right? Okay, so I would like you for this other part here is to find a 3-dimensional object in your environment. So maybe it's outside, maybe it's inside, that has some symmetry to it, and describe the symmetry. And maybe it has reflective symmetry and rotational symmetry. Maybe it just has reflective symmetry. Maybe it just has rotational symmetry. Just find something that has some symmetry and share it with us. And a photograph is great. So I will share some photographs soon. And that's it in this section. We have reflectional symmetry and rotational 2D. It's the 3D stuff, we're only doing this little part here because it's just way harder to work with 3-dimensional stuff. Oh, Olivia, you made last week a figure. You made an icosahedron, didn't you? Let me go look that up. That was cool. Let's see, discussions, cool 3D objects. So let's pick on Olivia here. So I had this sucker right here, and this thing, so from last week, I was rethinking it. Let's see, did I write my thoughts on this? That it might be what's called a stellated, and I put a link to what stellated means, polyhedron, but actually I don't think it is a polyhedron. And someday soon I'm gonna go back to Corvallis this year and I'm gonna check that thing out and I'll have to report back to you, but I don't think it's gonna be this quarter. That place is so wild, isn't it? I gotta check that out. I go to Seattle all the time, but I've never been there for some reason. All right, okay, so Elsie had this one in her house, and then Olivia made one of those. Where is that? That is actually a giant soccer ball. I think I made a post about that here. It's a truncated rhombic blah, blah, blah. Yeah, that's what it is. Okay, crystals. That was cool. The polyhedral thinker. Oh, Olivia, there we go. All right. And looks like I've already opened this here before. Let's open it again. Q-tips and hot glue, way to go. My internet's a little slow. Maybe it's all this rain. Yeah, that is awesome. Look at that. So the tetrahedron, actually all of the platonic solids have, I think they all have planar symmetry, and I think they all have rotational symmetry. I know they all have rotational symmetry. The planar symmetry is a little harder. I'm pretty sure they all do. So that would be, you could post that for your 3D object. Again, or you could do something else. It's up to you. But yeah, this icosahedron, which is triangular sides, and it's got 20 of those triangular sides, faces, excuse me. That's a cool one. All right, so I'm out of stuff for today. That's all that really goes on in section 10.4 of our book. My account at McGraw-Hill, where our textbook is from, is messed up. I've written to them. I'm waiting for a reply. At the moment, I cannot post any new reading assignments. So unless they fix my account tomorrow or the next day, we're going to have to do the reading assignments different than before. And I got a couple of ideas. So I'm pretty sure there aren't any reading assignments for chapter 11. Is that right? Can someone help me verify that? Let's see, assignments. Oh, there we are. Oops. Where the reading. Yeah, I didn't get the 11 posted yet. We are going to start chapter 11 next week. First chapter, section 11.1 is on measurement, so we will be working on that together next week. There will be a reading assignment, but it may not be like these, where you go into that woman who talks to you and asks you questions. Maybe a little bit different, because at the moment I cannot get into my account at McGraw-Hill to add any new assignments, but I'll figure something out. Does anybody have any questions for me or the group? No questions at the moment. I'll pause in case anyone's typing. I wish the Zoom chat would let me know when people are typing. That would be good to know. Like what, I think what Snapchat does that, if I remember right. Get this little note, so-and-so is typing. Zoom needs to include that maybe, or that could be annoying as heck with a big class. Okay, so it looks like no one has any questions. So I'm done with the stuff I had to present for this week. There's a recording of me doing some of the same stuff I did today with the pattern blocks for this activity. And that is in the homepage YouTube playlist right here. And this recording will end up there shortly. So take care and do good math unless you have anything else here.